Properties of ionic compounds. In the last lesson, we learned the formation of ionic compounds. The examples were like sodium chloride. Sodium was a positive ion, chlorine formed a negative ion, and there was a strong force of attraction between them, resulting in the formation of sodium chloride. Same thing for magnesium oxide. Magnesium formed a cation, positive 2, by giving out 2 electrons. Oxygen formed an anion by accepting 2 electrons. And then there was a force of attraction between this positive and negative, forming magnesium oxide. So all ionic compounds are made up of ions. Ions are positively charged, called cations, and the negatively charged, called anions. In this case, sodium was a cation because it was positively charged, and magnesium was also a cation. The anions here were chlorine and oxygen. So ionic compounds are compounds that are formed of ions. Today we will learn the properties of ionic compounds. Here in this picture is an example of sodium chloride. Now sodium chloride are made up of 2 ions. The sodium, which is a smaller, and it is positive because it gives out electrons, and we have the chloride ion, which is negative because it accepts the electron. And there is a force of attraction between this positive and this negative called the ionic bond. So in this picture we see that there is chlorine here, then there is sodium positive, then there is chlorine negative, and here you have sodium, then we have chlorine, we have sodium, one positive and one negative. They are held together by the electronic force of attraction. They aren't able to move much because there is a strong force of attraction, and this results in a proper crystalline regular structure of the crystals. So when you see the first property of ionic compounds are usually crystalline solids. Why are they crystalline? They are solids because they have oppositely charged ions. The ions attract each other strongly and form a regular crystal. There is a proper arrangement of ions because you have the positive, the negative, positive, negative alternating with one another, forming a proper crystal of sodium chloride. Now for the next property, we have ionic compounds have high melting and boiling points. To explain this, we know ionic compounds are made up of ions. Let us take the example of sodium chloride. Here is a sodium ion, positive, and the chlorine ion, negative. Now you could just wonder, why have I drawn the sodium ion smaller while the chlorine ion larger? Because if you go back and remember, the sodium ion has got just 2 shells, 2 and 8, while chloride ion has got 2, 8 and 8. However, this is not important for the melting point. So sodium chloride or ionic compounds are made up of positively charged cation and negatively charged anion, held together by a strong force of attraction. And now if you want to melt it, you have to break this force of attraction. And since the force of attraction is very high, very strong, you need a large amount of energy. So here we see, in order to break that force of attraction, a lot of energy is required, means a lot of heat is required. So the melting or the boiling point is very high. Now it is in a liquid state, so there may be a slight attraction between the sodium ion and the chlorine ion. So let's read this now. So ionic compounds are made up of positively and negatively charged ions. There is a strong force of attraction between the oppositely charged ions. Hence, a lot of energy is required to overcome this force of attraction. So ionic compounds have a high melting and boiling point. Now we'll learn about the solubility of ionic compounds. Ionic compounds are soluble in water, but they are insoluble in organic solvents like ether, acetone, benzene, kerosene, carbon disulfide and carbon tetrachloride. So in water they dissolve, and we have seen that how salt dissolves in water, how copper sulfate dissolves in water and forms a clear solution. But they do not dissolve in these organic compounds like ether, acetone, benzene, kerosene. These are all organic solvents. And an ionic compound do not dissolve in this. Now let us first understand why this happens. Here we have three molecules involved. Here is the water, which is H2O, and in H2O the oxygen is slightly negative and the hydrogens are slightly positive. Here we have the sodium, which we know is positive, and the chlorine that we know is negative. So if you notice up here in the first picture, we have a molecule of sodium which is positive, and because the water has got a slight charge, we find the negative gets attracted, the negative oxygen gets attracted here to the positive sodium. And in the next picture you see the chlorine is negative, and because this chlorine is negative, the positive hydrogen gets attracted towards it. In the next picture again we see we have the negative chlorine and the positive hydrogen is getting attracted around. Look at this, what is happening here. There is a force of attraction between this positive and negative here. Whereas if you go to see in this picture, now there is a force of attraction between the positive and negative, the positive sodium and the negative oxygen. And because water has got the slight charge, it's able to separate the sodium and chlorine ions. But when it comes to organic solvents like ether, acetone, benzene, kerosene, they do not have this slight positive and negative charge, and they're not able to separate out the sodium and chlorine. So ionic compounds which are made of ions dissolve in water. Most of them dissolve in water because water also being slightly charged, I'm using the word slightly charged, it's very important to use the word slightly because it's a covalent compound. So water being slightly charged can separate the positive and the negative ions. This charge on the water weakens the force of attraction between sodium and chlorine, or for other ionic compounds between the positive and the negative. To go back to what we need to know is ionic compounds are soluble in water, insoluble in organic solvents. Here's another picture to show how sodium, which is in the center and positively charged, gets surrounded by oxygen from the water, which is all negatively charged. Slight negative charge, not a strong. You can't call water ionic. Water is covalent. There is a slight charge on the positive because the electrons are not shared equally. You will learn that in the higher class. Ionic compounds conduct electricity when dissolved in water or when melted. So we have already learned that ionic compounds are made up of ions, and the ions have a strong force of attraction, and these ions are not able to move freely. And the conduction of electricity requires just not ions, they require free ions, ions that are able to move. So although the ionic crystalline form of ionic compounds are made up of plenty of ions, but the ions are fixed. They are not able to move. And why are they not able to move? Because of strong force of attraction. So here is sodium and chlorine, positive, negative ions are present, and the force of attraction is so strong that the sodium and chlorine are held together and they are not able to move. So crystalline form of or solid form of sodium chloride or any ionic compound does not conduct electricity. But however, if you melt this sodium chloride, like in this case, once you melt it, the ions now become more free, or when you dissolve it in water, the ions are now more free, and in this state they are able to conduct electricity. In the next picture here you can see we have the positive and the negative. Here we have the negative electrode, here we have the positive electrode, and you will find that all the positive ions here, these positive ions which are now free, will all rush towards the negative. These are the positive and they will rush towards the negative, and all the negative, now that they are separated and the force of attraction between them is very less, they will now rush towards the positive. If there is movement of ions, we have electric current. So to go back to this point, ionic compounds in solid state do not conduct electricity. And why? Because the electrons, the ions are not free. No free ions. Ions are held tightly by the electrostatic force of attraction.